All right, so today's goal is to find the domain and range algebraically. So this is going to be without a graphing calculator. So you can think of the graph mentally, what it would look like, and then use that to help you. But I don't want you using your graphing calculator to check for the graph. We're going to do this all algebraically today. So when finding the domain of your function, you want to ask yourself what values can't be in the function. I shouldn't say function, let's say equation, because we know some of them aren't functions. Right. What restrictions do we have?
Please excuse the interruption. All students going on the MadFest field trip, please report to the lobby. Thank you.
So we're looking for exceptions, and I've talked about this before. The polynomial functions will be the set of real numbers, and that's like what the real R looks like in a font. The real numbers, but we know we write like this. Except there are two exceptions, and we've talked about them. Square roots and fractions. So the first one is your square root. You cannot have a negative under the radical. And I should say under the radical of an even index. So a square root, a fourth root, a sixth root, an eighth root. You can have a negative under the cube root, right? Cube root of negative 8 is negative 2. So it's just when you have a square root. So anytime you'll see this, what you're going to do is take the radicand, which is whatever's underneath, and tell me it has to be positive, greater than or equal to 0. And then you solve out for x. So this one would be 3x plus 3 is greater than or equal to 0. Subtract 3. Divide by 3. And we'll get that our domain would be x is greater than or equal to negative 1. If you prefer to then switch that back to like your parentheses and brackets, it would be like negative 1 to infinity. But if you already have the inequality, I'll just leave it. Now, when you find the range of this function, you will have to think through like what values would exist in the y values for the x values. And sometimes the table of values is the best way to go. So when we plug in negative 1, and we would pick numbers that are bigger than negative 1. So like 0, 1, and 2. You don't have to do a ton of them. You just have to figure out if the graph is going to be increasing in the y values or decreasing. So when you plug in negative 1, we end up getting 0. When we plug in 0, we'll end up getting the square root of 3. We don't know what that is, but. And when we plug in 1, we'll get the square root of 6. When we plug in 2, 3 times 2 is 6, plus 3 is 9, square root of 9 is 3. So you can see that your y values are increasing. The smallest it ever is 0. So for the range there, we would say y is greater than or equal to 0. So the domain is found using algebra. The range is found by thinking about a table of values and seeing how the y values would match up with those x values. Now our other stipulation is that we cannot have 0 in the denominator. And if you remember, when you divide by 0 on your calculator, it gives you that like error, okay, undefined. So anytime you have a denominator, you'll say that it cannot equal 0. So x minus 4 cannot equal 0. We did this back in chapter 5 when we did radical expressions. Add 4 to both sides, so we would say that the domain would be all real numbers except x cannot equal 4. Or you could just put comma, x cannot equal 4. And I'm not going to make you do the range for radical functions yet because we actually have not graphed them, but it will be like a union type situation. But usually whenever you see these, you're just going to see a domain line because we haven't looked at graphing those yet. We will eventually, but I'm not going to hold you to the range yet, just the domain part of any of the rational functions. Okay. All right, so we have a whole mixture of problems here asking us to find the domain and range. Remember, if you don't have a square root or a fraction, your answer is all real numbers, okay? For the domain at least. So the first one, no fraction, no square root. This would make a quadratic, so the domain is all real numbers. Now, when the domain is all real numbers, that does make the range a little bit harder because you don't have numbers to plug in, right? So you actually probably, for the range, want to think about the graph mentally. So quadratic, it's been reflected downwards, and it's been shifted up 2. So you're using your knowledge of transformations of quadratics back from chapter 5 to help you figure out. So now we can say that the range is going to be less than or equal to 2, or you could say negative infinity to positive 2, whichever one you prefer. All right, the next one has a square root. And you could simplify this to see what type of stretch and stuff is going on. Remember, you can factor out a GCF. You don't have to do this, but remember I showed you how you can do that. And then you can take the square root of 4, which would then become 2. And so we would end up getting negative 6 square root of x plus 4 plus 3. So if you want to simplify it, it could help you to see, like, I don't know what's going on with the stretch or the shrink. So this one is going to have a restriction on the domain because we have a square root. So again, we say that the radicand has to be greater than or equal to 0. So x plus 4 is greater than or equal to 0. Therefore, x is greater than or equal to negative 4. Now for our range, again, you could like picture the graph for this one using your transformations if you like. This would be left 4, right? This would be up 3. The negative would be flipped downward. And then it would be a stretch of 6, meaning it's like steeper. If you want to graph it, or you can do your table of values, whatever you want. So for a table of values, we want to pick negative 4 as our starting number because that's the equal to. And then anything bigger than that, just pick a couple of them. And sometimes we won't get an answer, but negative 4 plus 4 is 0. Square root of 0 times 0 is 0.
Please excuse the interruption. Sarah Hardy, if you are going on the field trip, please report to the lobby. Thank you.
Negative 3 plus 4. Give me 1. The square root of 1 is 1. Negative 6 plus 3 will get me negative 3. So it's important to notice that the y values are actually decreasing, and that's because the negative is telling you that that would be flipped downward. So I say 4 to the left, 3. So it'll be something like this. Okay, you really don't have to keep going. As soon as you see if it's going positive or negative, that'll tell you what inequality to use. So we're going to say that the y values have to be less than or equal to, smaller than or equal to 3. All right, now the next one has a square root. However, the index is odd, meaning we don't have any restrictions on the variable. If you remember the graph of these things, look like this. Well, they actually normally go up, but since we have a negative, I drew it going downward. So what is the domain and range if we have a graph of this? Okay. All real numbers for both. So even though it is algebraically, you still need to think graphically sometimes in your head. All right, the next one, we have a fraction, a rational equation, which this is actually what chapter 9 will be on, our last chapter that we get to this year, rational functions. So sometimes you will have to factor and simplify, like the top and bottom. But in this case, we're just going to go ahead and say that the denominator can equal 0. And solve for x. So the domain would be all real numbers. except that x cannot equal negative 2. Number 5, what do you think for the domain? We have a quadratic example. All real numbers, no square roots. Oops. No square roots and no fractions. How about the range? Be careful, think of the graph. Shift it down to stretch of 3, which doesn't really matter. Ashley? Good. Y is greater than or equal to negative 2. Or, bless you, bracket negative 2 to infinity, whichever you prefer. The next one, again, we can simplify if you'd like to, and this might help you. Next week we're going to do a matching graph activity where I'll give you like 10 equations and 10 graphs. You have to like match them up. So sometimes it is helpful if you have a GCF to take it out. And then we can square root 25 to get 5 times the square root of x plus 2 minus 2. Simplifies your numbers too, less mental math to do when you plug in values. So we do have a square root function, so what should my domain be? Jade? Good. We take our radicand and we say it has to be positive, greater than or equal to 0, subtract 2. Now, for our range, again, think about the shift left 2 down 2, or do a table of values and figure out, starting with negative 2, and we're going bigger than that, so negative 1, 5 minus 2 is 3. So you really only have to do 2 values just to see that that isn't, it's getting bigger. So it would be y is greater than or equal to negative 2 also. And that's because when I plug in negative 2, I get 0, 0 times 5 is 0, 0 minus 2 is still negative 2. Just kind of a coincidence that they're the same. Alright, we're not going to do all of them on the back, but we will do a couple, select few that I think are important. And I want to make sure we do the closure because that's going to review the inverse a little bit. So, this one has a quadratic in the denominator. So you probably do want to factor this. The only thing you can do to factor is take out a GCF. So you can take out a C. And then we will, you'll see again, I didn't put the range here because it's a rational function. We're going to tell us that the denominator can't be 0, can't divide by 0. Now you have to tell me each of these cannot be 0. So you're going to get 2 restrictions on your domain. C cannot equal 0, and C cannot equal negative 3. Because C plus 3 cannot equal 0, we'd subtract 3 on both sides. So it would be all real numbers except C cannot equal, and you can actually put 0, comma, negative 3. You don't have to put the do not equals twice if you want to shortcut it. We have 2 restrictions or 2 holes in your graph. Do you think we need to go through more, or do you guys think that you could do them on your own? On your own? All right, let's do the closure then. So the closure is one of those big, long questions. You remember before our little Easter break we had, they would ask you like 7 questions in one problem. Okay, that is going to be on your quiz next week. So I threw it in the closure. It's also on your homework tonight to practice. So they give us a function. First of all, they ask us what the domain is. So what would the domain of this original function be? Garrett? X is greater than or equal to negative 1. Very good. And wait a minute. What will the range be? Range is actually the harder part because you have to think about it. Jade? Very good. And doing your table of values, we'd have negative 1, 0, 1. Whenever you plug into those, you will see that you'll get 0, you'll get the square root of 2, you'll get 2, so you'll see that the y values are increasing. So that's why we use the greater than or equal to. Who remembers how to find the inverse of a function? Caleb? Good, you switch around your variables. So normally it's x and y, but you can switch around the f of x if you want. Some students like to change that to a y just to make it a little easier. So we'd have x equals the square root of 2y plus 2. Switch your variables and then solve for y. What would I do first to solve for y? Square it. And then you guys know how to do it from here. Subtract 2 and divide by 2. And usually we'll change that, since this is f negative 1, the inverse notation, I'll change that back instead of y. So this is one possible answer. Or if you want to split it up, it will be 1/2 x squared minus 1. Same thing. Who remembers the relationship between the domain and range of the inverse in contrast to the original function? Caleb? They reverse. So remember, the domain and the range switch just like the x's and the y switch. So we will end up with, the domain will be x is greater than or equal to 0. You do have to change the letter to an x. And the range will become what the domain was, y is greater than or equal to negative 1. Do not just think about this function on its own, because when you're doing an inverse problem, you do have to think of the original one. Okay? Since this was really only half of a square root. This would, if you think of it on its own, would give you a whole parabola of it. It's only actually half. And is this final equation, is this a function? Yeah, I just drew it right. Yes. All right, I'm going to let you guys go ahead and get started on the homework. You can skip the note problems. Go ahead and do the next worksheet. I think, let's skip some of them though, because I know on the back, well, it wouldn't hurt you guys to remember to do this. Nope, do them all. Some of you struggled on those equations at the bottom. I'd like you to practice them again.